Hello, here we have today what I'm going to show you is the simplest way to estimate the quantiles and the distribution of an extreme value and the extremal index, which is the variance at risk under various extremes. Now, there's a lot of libraries. The libraries you need aren't really there. I use them for other things. So disregard that. Now we are going to load the SPY data, as the SP500 is the bellwether index, a good one to track for extreme values. Although you can do it on individual shares, which is probably a good policy, although it's always a good idea to track the bellwether index. Anyway, as a tip, when you use get symbols, if you want to put, as you do, assign the symbol to a variable with get symbols, you have to do it by setting auto assign to false. Otherwise it assigns it to the symbol name. Okay? I've come across that problem for a while. It took me a while to figure out. We're not all that smart on the uptake sometimes. Anyway, whoops, we'll go back up and we'll run the code. Now I'll just run this. SP get symbols. We have SP. We'll have a look at SP to show that it's the S&P 5, the SPY data. There it all is. And we'll put SP equals daily returns SP. Okay. And we'll have a look at the structure of SP. And it's a nice XTS object with the date and the character daily returns and the data. And we want to find the threshold before we use our simple graphical user interface for finding this very helpful data. Now, this is really the only command I'm going to show you this. This comes from Alexander McNeil's eVia package, which is up here. I've loaded it up here. eVia. You can also, it's also mimicked in RMetrics FX Streams package. Slightly different name. Find threshold, not find thresh. Same thing, except that's more elaborate. This is good enough for our purposes. Now, we find the threshold of the downside. I put 1,000 as the data. What's gone wrong here? That's the data frame. We'll go back and do it again. There it is. That's the threshold. That is actually XT data. That had been, I'd converted it to a data frame down here, as you can see. It won't work with find threshold. But in order to run it in, not sure who writes the extreme package. But anyway, in order to run that, things have to be then converted back into data frames. And here we want to collect daily return with the date range. And this is how it's achieved. S is a variable, SP daily return. I assume you know this, but I'm going into more detail than I usually do. I usually rush things through, but this is only going to be a short video, so it's okay. You just type that brings it up, so there's only one variable. Bring it in. Now we'll convert it together. We'll check it. They're combined, and we'll turn it into a data frame. And we'll check the data frame. Nice, that's what we want. Now write it to a CSV file. Yeah, alright, okay. I wonder what it was written. I think, yeah, okay. Into Extremes is the library we want to run. That is the library we want to run. Extremes is the parent library. This is a teaching graphical user interface, which is sufficient for people to use for stock market data. Now, Extremes is for weather, things like hurricane forecasting, really complex stuff. The stock market can be used in a complex way, but it's generally not needed. This is, the simple graphical user interface is enough. So you don't need to go into the detail of Extremes itself. We'll run that. The library's loaded. And we'll run the graphical user interface, which I've already got down here. I'll run a third copy. I've been experimenting to make sure I get it right. Okay. And let's see, how many copies have I got it now? 3 copies. I better run the third copy. Alright, now we've got to import the data. You've got to be careful about this. It took a while to figure this out. Now, you go down, it's in my quick trading stats project file, and it's a CSV file. It's the SRAT. So I'll click on it. It's a common file. We don't want to use R source. You can, but it makes things difficult. It's for saving for later to come back. I find you can generate it so quickly again, it doesn't matter. Now, it's got the header, it's comma delimited, it's a CSV. Don't save it as, because it's not an R source. Click OK, and it's imported. Now, we'll go to Analyze. This is where we estimate the extreme values. Now, it converts what we imported, so you can't see it there because of the way I did it. It's inverted it into an into extremes data file. And there it is, the daily returns, okay? Click on that. And we'll look at the generalized extreme value distribution first and the Pareto. I found that the Pareto is a better fit, but it's not always, but point process was okay too. They are reasonable fits for stock market data. You got to bring it up because down there. Now here's where we put in that's where we needed to find our threshold. If you've forgotten, we'll have a look back up here. Remember the find threshold command? Oh, here it was. Find threshold. It's 0.005. I'll just round it because it's okay. Well, I'm saying it's okay whether it is or not. Okay, now just for illustrations purposes, I put a naught in front of it, 0.005. Now that's our threshold. I'm not sure what the response units is. I think it means days. Oh no, that says time units. Response units. I think that must be seconds or hours. I've left that blank and it doesn't, when we plot the diagnostics. Now these functions are, I don't muck around the log link scale parameter, I don't muck around, I just take those as defaults. If you want to research more, you can muck around more. This is set up for ease of use for beginners. And it's good enough for the stock data, it's reasonably accurate. Okay, and there's the fit. You can see it's sort of a gumball type of distribution on the tail. The original distribution was peaked, as a SPY is, and that's the fitting of the tail, a gumball to a distribution. It's not, the return period does not particularly, according to the estimate, it doesn't, you can see the regression line here, straight through. It doesn't match regression, it matches the regression line, okay, 95% confidence band, sort of there and there, it's sort of within it. And the 1-1 line is, it's not that great a fit, and that's also reflected by the quantile. You can see at the edges, it's not a great fit. I think you'll find the Pareto fits better. But anyway, it still presents quite a reasonable result. There's lots of other things you can do with this, but really for the stock market, what you want to know is the extremal index, which is sort of akin to this VAR. Click on that, click on that, click on that. We'll put just 0.005. And I like runs rather than intervals. Well, I'll do an interval and compare. Runs looks a more reasonable answer. I can't say why, I haven't looked into it in depth, but just from the point of view of, I know from lots of experience mucking around with extreme value distributions and things, run seems to give a better result. Now that looks all okay, yep, we'll run it. Thinking. There we go. And yeah, we've got a extreme index of about, which at this point in time when the market's going up, I think that's pretty reasonable to believe. The extreme event wouldn't be much more than 0.716 on the downside, and a maximum estimate of 7.4, an absolute upper of 0.76, maybe 0.77. I suppose this is not a very long video, so I'll just waste your time a bit more, and we'll test the interval and see what that says. And we'll also try, we'll try the interval. We'll leave it as interval. We'll get into extreme data, select data returns, put the threshold. Okay, we'll see what we get. See, it doesn't quite make sense. It gives an extremal index of 0.9, which is quite high for the lower estimate, and an estimate of 100%. One. I mean, let's see, if that's 0.94 points, that's saying 1 point. 0.94%, that's 0.94% is the downside. That is saying that the extreme and the upper extreme are 100%, which doesn't make sense. It's not rational. So we won't bother with that. I don't suggest you use the, what was that? The intervals method. Use the runs. And I think we've seen enough of that. I just leave it at run length 1, because the more runs you add, the higher the score you get, and it tends to be a bit more obscure too. I mean, I'm quite sure the fellows that run this could explain it better, or that made it. Likelihood ratio test, that's a statistical test of whether it's the likelihood ratio test from statistics. Parameter confidence intervals, Poisson distribution. We'll run a Pareto test. Okay. Data returns. We'll run a Pareto. Plot diagnostics. Pareto generally fits better than the general extreme value distribution, or it has in the past. I think it's a bit more robust. We'll run it. Fit to it. Gee, it fitted quick. As you can see, the Pareto really captures the downside really well. It's a nice fit there, and it really captures the line there. I think Pareto is probably a better fit for modelling. Well, I don't think, I know. Okay, now let's estimate the extremal index. I know, that is independent of the fit. We've got the diagnostics from the fit, so what else can we tell from the likelihood ratio, fit summary? I think the fit summary we've already got. Yeah, I mean, that's already what we've got. Yeah, that is just what we've got. We'll go to plots. I mean, this scatter plot will just merely show you the returns. If you've ever seen daily returns, you'll know what this looks like. That's a chart of returns around naught. Goes to -10. You can see this year there was a few serious down days. A serious down day of greater than -10%. And yeah, that's about 2010. 2009, I think. I think I said it as 2007. I think that's definitely this year. Last year, I mean 2020. The March event. Anyway, that's not a particularly remarkable chart. It's handy, but not remarkable. Mean residual life plot. Let's see what we get here. Daily returns. Okay. Yeah, that's shows it's a pretty good fit threshold. Shows that it's about right. That they go up and up. That the extremes. The further out you go, the greater the extremes. To -8, you get a drop of 8%. Okay, that's not particularly remarkable. Let's see, fit diagnostics. I think we've done that one. Return level plot. I think this one might be interesting. We'll try fit 2 because that's a better fit. Have a look. Oh, that's just one of those. That's just part of that chart. You can see the fit. Returns projected. We'll have a look at model fit 1. Fit 1. Yep, that's just that picture again. You capture more with a general extreme value distribution. Perhaps that's why it doesn't fit so well. It captures far more data. Let's have a look at some of the other plots. Fit pot model to a range of thresholds. We've already done that. One threshold. We don't need to do a range of thresholds. You can for interest's sake. Let's see what this is. Mean residual life plot, daily returns. I must have already looked at that one, yeah. Auto dependence function, okay. Daily returns. It's sort of like a auto dependence, yeah. It's like a we call it auto correlation function. You can see that tends to be constant auto dependence in the actual variable values on the mean values. It tends to be virtually nothing. Okay, decluster transform data. There's quite a lot you can do, but you can get what you need quickly, which is the basics, the very basics. You know, with one of the methods you can get a good model fit. You can get a good extreme index, which that one's not so good. We'll go up to the original one. With the runs, you get a good extreme index. Ferrosag's bootstrap. There. No, that's a good index. Maybe you could get better if you muck around with these, like run lengths and things. I'm not sure. Anyway, that's enough for me today. Hopefully you find it helpful. Extreme value theory mathematics is incredibly complicated, and you get lost calculating it, and I've spent quite a few months on it, and I can do a lot better graphs and find a lot better things, but this I found is really quick and efficient when you need results fast. And you're not particularly interested in the mathematics of it all. Okay, thanks, bye.